Today we are going to discuss some of the problems on properties of the transform. First problem, find the transform of the signal x of n is equal to u of minus n. It is given x of n is equal to u of minus n, and we know that the transform of u of n is 1 divided by 1 minus z inverse with mod z is greater than 1, and using time reversal property, u of minus n, if we take the transform, we get 1 divided by 1 minus 1 by z inverse with mod z is less than 1. Therefore, u of minus n, if you take the transform, we get 1 divided by 1 minus z with mod z is less than 1. Second problem, find the z transform of the signal x of n is equal to 3 into 2 to the power n into u of minus n using appropriate properties. It is given x of n is equal to 3 into 2 to the power n into u of minus n. Or we can write x of n is equal to 3 into half to the power minus n into u of minus n, and we know that the transform of half to the power n into u of n is 1 divided by 1 minus half z inverse with mod z is greater than half, and using time reversal property, half to the power minus n into u of minus n, if we take the transform, we get 1 divided by 1 minus half z with mod z is less than 2, and using linearity property, 3 into half to the power minus n into u of minus n, if we take the transform, we get 3 divided by 1 minus half z with mod z is less than 2. Find the z transform of x of n is equal to n into alpha to the power n into u of n using appropriate properties. We know that u of n, if you take the transform, we get z divided by z minus 1 with mod z is greater than 1, and using scaling in the z domain alpha to the power n into e of n. If you take z transform, we get z by alpha divided by z by alpha minus 1, which is equal to z by z minus alpha, with mod z is greater than mod alpha. And using differentiation in the z domain, we get n into alpha to the power n into e of n. If you take z transform, minus z into d of z by z minus alpha divided by dz, which is equal to z alpha divided by z minus alpha whole square, which is equal to alpha z inverse divided by 1 minus alpha z inverse whole square, with mod z is greater than mod alpha. Next problem, using appropriate properties, find the z transform of x of n is equal to n square into half to the power n into u of n minus 3. It is given x of n is equal to n square into half to the power n into u of n minus 3, or we can write x of n as half to the power 3 into n square into half to the power n minus 3 into u of n minus 3, which is equal to 1 by 8 n square into 1 by 2 to the power n minus 3 into u of n minus 3. We know that half to the power n into u of n. If we take z transform, we get 1 divided by 1 minus half z inverse, with mod z is greater than half. Then using time shifting property, half to the power n minus 3 into u of n minus 3, if you take z transform, we get z to the power minus 3 divided by 1 minus half z inverse, with mod z is greater than half. Except z is equal to 0. That is equal to 1 divided by z cube minus half z square. Then using differentiation property, n into half to the power n minus 3 into u of n minus 3, if we take z transform, we get minus z into d by dz of 1 divided by z cube minus half z square, which is equal to 3z cube minus z square divided by z cube minus half z square whole square. So n square is given, so twice we have to do the differentiation. Again, using differentiation property, n square into 1 by 2 to the power n minus 3 into u of n minus 3. If we take z transform, minus z into d by dz of 3z cube minus z square divided by z cube minus half z square whole square, which is equal to z to the power 4 into 9z square minus 5.5z plus 1 divided by z cube minus half z square whole cube. Then using linearity property, we get x of n is equal to 1 by 8 n square into half to the power n minus 3 into u of n minus 3. If we take z transform, we get 1 by 8 into z to the power 4, 9z square minus 5.5z plus 1 divided by z cube minus half z square whole cube. This is the answer. Find the z transform of the signal x of n is equal to n sine pi by 2 n into u of minus n. It is given x of n is equal to n sine pi by 2 n into u of minus n, or we can write x of n as minus n sine minus pi by 2 n into u of minus n. And we know that sine pi by 2 n into u of n, if we take z transform, we get sine pi by 2 into z inverse divided by 1 minus 2 cos pi by 2 into z inverse plus z to the power minus 2 with mod z is greater than 1, which is equal to z inverse divided by 1 plus z to the power minus 2 or z by z square plus 1. Then using differentiation property, n sine pi by 2 n into u of n, if we take z transform, we get minus z into d by dz of z by z square plus 1 with mod z is greater than 1, which is equal to z cube minus z divided by z square plus 1 whole square. And using time reversal property, we get minus n sine minus pi by 2 n into u of minus n. If we take z transform, z cube minus z divided by z square plus 1 whole square, which is equal to z into 1 minus z square divided by z square plus 1 whole square with mod z is less than 1. Using the appropriate properties find the Z transform of x of n is equal to sine pi by 8n minus pi by 4 into u of n minus 2. It is given x of n is equal to sine pi by 8n minus pi by 4 into u of n minus 2, or we can write it as x of n is equal to sine pi by 8n minus 2 into u of n minus 2, and we know that sine of pi by 8n into u of n, if you take the transform, we get sine pi by 8 z inverse divided by 1 minus 2 cos pi by 8 z inverse plus z to the power minus 2. Using time shifting property, we get sine pi by 8 into n minus 2 into u of n minus 2. If we take z transform, we get z to the power minus 2 into sine pi by 8 z inverse divided by 1 minus 2 cos pi by 8 z inverse plus z to the power minus 2, with mod z is greater than 1, or if you take z transform, after simplification we get 0.383 z to the power minus 3 divided by 1 minus 1.848 z inverse plus z to the power minus 2. Using appropriate properties, find the z transform of x of n is equal to alpha to the power n into sine ohm naught n into u of n. We know that sine ohm naught n into u of n, if you take the transform, sine ohm naught of z inverse divided by 1 minus 2 cos ohm naught into z inverse plus z to the power minus 2 with mod z is greater than 1. And using scaling in the z domain, we get alpha to the power n sine ohm naught n into u of n. If you take z transform, alpha sine ohm naught into z inverse divided by 1 minus 2 alpha cos ohm naught into z inverse plus alpha square z to the power minus 2, with mod z is greater than mod alpha. Find the z transform of the signal x of n is equal to half to the power n into u of n convolution with 1 by 3 to the power n into u of n. Let x1 of n is equal to half to the power n into u of n, then x of z is equal to 1 divided by 1 minus half z inverse, with mod z is greater than half, and x2 of n is equal to 1 by 3 to the power n into u of n, then x2 of z is equal to 1 divided by 1 minus 1 by 3 z inverse, with mod z is greater than 1 by 3. Then x of n is equal to x1 of n convolution with x2 of n, and using convolution in time domain, x1 of n convolution with x2 of n, and if we take z transform of that, we get x1 of z into x2 of z. Therefore, x of n is equal to half to the power n into u of n convolution with 1 by 3 to the power n into u of n. If we take the transform, we get 1 divided by 1 minus half z inverse into 1 minus 1 by 3 z inverse, with mod z is greater than half. Find the z transform of the signal x of n is equal to n into half to the power n into u of n star half to the power n into u of n. From convolution property, we can write half to the power n into u of n convolution with half to the power n into u of n. If we take the transform, we get 1 divided by 1 minus half z inverse into 1 divided by 1 minus half z inverse, which is equal to 1 divided by 1 minus half z inverse square, with mod z is greater than half. And using differentiation in z domain, we get n into half to the power n into u of n convolution with half to the power n into u of n. If we take z transform, minus z into d by dz of 1 divided by 1 minus half z inverse square, which is equal to z inverse divided by 1 minus half z inverse cube, with mod z is greater than half. Given x of n, if we take z transform, we get x of z, which is equal to z by z square plus 4 with ROC mod z is less than 2. Using the properties, determine the z transform of the following signals. First one, y1 of n is equal to 2 to the power n into x of n. It is given y1 of n is equal to 2 to the power n into x of n, and if we take the transform of x of n, we get x of z which is equal to z divided by z square plus 4. It is given with ROC mod z is less than 2. And using scaling property, we get y1 of n is equal to 2 to the power n into x of n. If we take z transform, we get y1 of z which is equal to x of z by 2 which is equal to z by 2 divided by z by 2 whole square plus 4 which is equal to 2z divided by z square plus 16 with mod z is less than 4. Second one, y2 of n is equal to n into x of n. Using differentiation property, we get y2 of n is equal to n into x of n. If we take z transform, we get y2 of z which is equal to minus z into d by dz of x of z which is equal to minus z into d by dz of z by z square plus 4 which is equal to z cube minus 4z divided by z square plus 4 whole square with mod z is less than 2. Next problem, find the z transform of x of n is equal to mod n into alpha to the power mod n with mod alpha is less than 1 using properties of z transform. It is given x of n is equal to mod n into alpha to the power mod n. We can write it as n into alpha to the power n into u of n minus n into alpha to the power minus n into u of minus n. So we can consider this term as x1 of n and we can consider it as x2 of n which is equal to x1 of minus n. And we have alpha to the power n into u of n. If we take z transform, we get z divided by z minus alpha with mod z is greater than mod alpha. Then using differentiation, we get x1 of n is equal to n into alpha to the power n into u of n. If we take z transform, z alpha divided by z minus alpha whole square which is equal to alpha z inverse divided by 1 minus alpha z inverse whole square with mod z is greater than mod alpha. And using time reversal property, x2 of n is equal to x1 of minus n which is equal to minus n into alpha to the power minus n into u of minus n. If we take z transform, we get alpha into 1 by z whole inverse divided by 1 minus alpha into 1 by z inverse whole square which is equal to alpha z divided by 1 minus alpha z whole square with mod z is less than 1 by mod alpha. Therefore, x of z is equal to x1 of z plus x2 of z, which is equal to alpha z inverse divided by 1 minus alpha z inverse whole square plus alpha z divided by 1 minus alpha z square, or alpha into 1 plus alpha square into z plus z inverse minus 4 alpha square, whole thing is divided by 1 minus alpha z inverse whole square into 1 minus alpha z whole square, with mod alpha is less than mod z is less than 1 divided by mod alpha. Find x of z if x of n is equal to alpha to the power n by 3 into u of n by 3, where n is equal to 0, 3, 6 and so on, and mod alpha is less than 1, using properties. It is given x of n is equal to alpha to the power n by 3 into u of n by 3, assuming y of n is equal to alpha to the power n into u of n, then x of n is equal to y 3 of n, which is equal to alpha to the power n by 3 into u of n by 3. And we know that y of n is equal to alpha to the power n into u of n. If we take z transform, y of z is equal to 1 divided by 1 minus alpha z inverse, with mod z is greater than mod alpha. And using time expansion property, x of n is equal to y3 of n, which is equal to alpha to the power n by 3 into u of n by 3. If we take z transform, we get x of z, which is equal to y3 of z, which is equal to y of z cube, equal to 1 divided by 1 minus alpha z cube minus 1, which is equal to 1 divided by 1 minus alpha z cube, with mod z is less than mod alpha to the power 1 by 3.